All right, guys, so we're going to kind of transition, we're going to shift gears a little bit. We're going to start talking about square roots, okay? This first unit, I just call it Unit 1. I've kind of pulled things from different sections of the textbook that I think it's important that we know before we get into like the first official chapter we're going to start with, okay? So that's why it's kind of a hodgepodge of things kind of thrown together. All right, so today, all I want to be able to do with you guys for today is just how to simplify a square root. Looking through your pre-test, a couple of you, I think, have an idea how to do this. Some of you may remember once I show you one, and some of you, I don't think have ever seen this before, based on what I saw. So simplifying square roots, if b squared equals a, then b is the square root of a. Square root. So for example, if 3 squared is 9, what's the square root of 9? It's 3. All right, what's the symbol look like? I love it, like 4 of you did that for me. You were correct. All right, your symbol looks like that. It's like a little check mark with a line over top. Also, it's referred to as a radical. So if you hear me say radical something, I'm not talking about like us totally gnarly, tubular, like that kind of talk. Yeah, no. Radical is what that sign is called, right? And it is simplified when all perfect square factors have been removed. Okay, so there's different ways to attack simplifying radicals, and some of you may have learned a different way than I'm going to show you, and that is fine. Me personally, if I'm simplifying radicals, I do them in my head pretty quick because I do it a different way than I'm going to show you. But I have found through, this is my 15th year of teaching, the way I'm going to show you is the easiest for students to understand, and you get fast at it. So as fast as I do it a different way in my head, you'll be just as fast as time goes on with these. Okay? Yes. Yep. I'm going to teach you with factor trees. I think it's the easiest way to do them for you guys. All right. So step 1, you are going to create a factor tree to find all the factors of the number. So factor trees, so for example, we started with radical 24. First thing though, make sure when you're starting to simplify these, make sure it's not a perfect square right from the start. I hate when people are like radical 36 and they start making their factor tree on it. What's the square root of 36? 6, right? It's okay. If it's perfect, then just go from there. But if it's not perfect, we do our factor tree. So in this case, I went 2 and 12. 12 broke down to 2 and 6. 6 broke down to 2 times 3. So you just keep going until you're at all prime numbers. A number doesn't break down any further. Okay? Now in this example, they're highlighted. You'll notice when I do them, I circle my primes. And I do that so I only then am looking at my primes in the next step. This does it a little differently than I teach it. So this says to list the factors from least to great. I don't do that, okay? I look for pairs, right? We're doing square roots. Square means 2, right? So we want pairs. So when I look at this, I'm like, oh, look, I have a pair of 2's. So if I have a pair of 2's, it comes outside. Think about it as you have a date. It's you and your date. The 2 of you together make one couple, and you get to go out to dinner together, right? The single people, they're lonely. They're sad. They stay in the house, right, underneath the radical. They stay inside watching Netflix together, eating ice cream, which doesn't sound so bad, right? Good. Oh, really? No, I see it because it takes 2 of you. So you have a pair. You're on a date. It's much more happy. All right, so then whatever's left over, the singles, they multiply back inside. If you have more than one couple on the outside, they multiply on the outside. Okay? So let's go ahead and try some of these. It makes more sense once you kind of get going with them. So number 1, one thing with me is, guys, no decimals. Okay? Don't write the decimals down. Yes? Oh, did it? Oh, I'm sorry. Sorry. Multiply the numbers on the outside and multiply the numbers left on the inside. Sorry. They changed the software that I use for this changed, and it used to just show up highlighted on your papers, and now it like blanks it out, doesn't it? Sorry. I'll have to change that. You're welcome. So number 1, radical 32. If you type it in your calculator, is it nice and pretty, or what's it give you? It's a crazy decimal, right? That keeps going forever, and there's no pattern to it, and it's ugly. Do not write a decimal answer for me, ever. Okay, ever. Do not write a decimal answer, ever. You put in radical 32? Hit enter. Yeah, I'm going to have to fix that one. That's not right. All right, so if it's not perfect, we do our factor tree. What do you multiply to get 32? 8 and 4. Now, some of you were like 2 and 16, and that's okay. Honestly, it does not matter how you do your factor tree, you'll end up with the same primes at the end. So there's always that one kid, divide by 2, divide by 2, divide by 2, divide by 2, and they do that until they can't go any further. And then they usually get stuck and don't think, divide by 3, divide by 3. So that's fine. If you want to go that route, by all means, you end up the same spot. All right, but I'm going to break down 8. Good. And 2 is prime, so I'm going to circle it. 4 is not, so I'm going to keep going. It'd be 2 and 2. And again, circle your primes. Okay, I still have this 4 up here. Let's break that one down. 2 and 2. Circle primes. Now, why would I ask you to circle the primes? Every year I have kids who choose not to circle them. Good, I know I'm done, right? Like I see the circles, I know that one ended, I don't have to worry about it anymore. Also, right now when I go back to look for pairs, which numbers am I looking at? I'm looking at those primes. I don't want to accidentally look at the 2 or the 4s and the 8 in there. I don't want to look at those because I broke those down. So I'm only looking at my prime numbers, the ones I circled. So we're going to look. Do we have a pair that gets to go out on a date? I got 2 pairs. So there's a pair. They came out as a date. It's either one couple, right? Only one of them comes out. And I got another pairs. They get to come out. And then who's left over? Just 1, 2 stays inside watching Netflix. And then the 2 that came outside, we're going to multiply those together. So we get 4, radical 2. Four square root of 2? You'll never hear me say that. Technically, it's not wrong, but it sounds weird. You could have. If you recognize that, yeah, you could have. Yeah. I'm going to guess that you would have looked at this and went, oh, that's radical 16 and radical 2. The square root of 16 is 4 radical 2. That's how I do them. Yeah. If you've learned that method, by all means, keep using it. Okay. The reason I teach it this way is just 15 years of experience. Students struggle because they don't know their perfect squares. But if you know them, please do them that way. Okay. If I did that and you're like, what the heck did she just do? Don't worry about it. It's okay. All right, so 54. 6 and 9. All right. Neither one of those are prime, right? 6 is going to break down. Okay, 2 and 3, or 3 and 2. And then 9, 3 and 3. But I will say, based on, I know you like this other method, which is what I normally do, there's times where I'm like, I can't think what the biggest perfect square is that goes into something, and I'll still find myself doing this as a backup. All right, do you have any pairs? Yeah, a pair of 3s. So those 3s come out together on a date, so there's just the 1 3. Good, and the 2 singles go back underneath as 6. Remember, you got to remember, singles are lonely. They have to stay inside together, okay? They don't get to go out on a date. All right, how about number here there was a group of 2s, and I had 2 groups that came out. No, great question. That's funny. The way, different ways people break things down. And to me, I look at number 3, and right off the bat, I don't have a calculator in my hands. So in my mind, I'm like, oh, that's 2 and 1 12. Like that's how I saw it. Doesn't matter. Doesn't matter. I'm going to go 2 and 1 12 because that's what I can do without a calculator in front of me. That's what I can do that in my head. And I know that's 2 and 56. That'd be 2 and 28. 2 and 14. 2 and 7. So regardless of where I started, where she started, and where she started, did we all end up the same prime numbers? Yeah, you do. I just get a really long kind of angled factor tree where your guys is probably branched more out wide. Totally fine. All right, what pairs do we have? Okay, so there's a pair of 2s, another pair of 2s. Good. The 2 singles go inside together, right? As 14. So 4 radical 14. Yeah, the biggest thing at this point, guys, to recognize is when you have a pair, they come out as 1. Because in other words, if you go back to the method that he was referring to, what is 3 times 3? That's 9. What's the square root of 9? That's why it's only 1 3 coming out. Okay, you're just finding those perfect squares from the same method that he was doing. All right, number 4, 3 radical 48. Now, there's a 3 on the outside, but he's just kind of hanging out, waiting for the other friends to show up, okay? So you can ignore him from the very start. Just ignore him for right now. Let's deal with just the radical, okay? 16 and 3. I love how you guys all go different directions. It's totally fine. All right, so 4 and 4, 2 and 2. So Donnie, you may be like I was in the last one. Divide by 2, divide by 2, divide by 2. You're just figuring out what 2 numbers multiply to give you that? So, I know. Some people come up with the most random, like... It's all right. We're still rusty. It's okay. It's totally fine. Yes. All right. So we have a pair of 2s. So they come outside. This other pair of 2s comes outside. I got a single 3. Singles stay inside by themselves. What about this guy? He's outside. He stays outside. Right? So he just comes down and he joins his friends outside. And then what do I do with all of these? Multiply. 3 times 2 times 2 is 12. And then radical 3. Were you okay with the factor tree that I did? Are you okay with making a factor tree? Okay. We were looking for pairs. I got a pair of 2s right there. So that one came out. And then a pair of 2s right here. That one came out there. Every pair you have, just one of them comes out. It's like the 2 of them make one couple, and they come outside together. So what about number 5? You too. I don't know what you're, if you're competing. I'm going to go basic. I look at that and go, that's an even number. I'm going to go 2 and 54. And I don't care where you go, as long as it equals out to be 108. I don't care. All right, so 54. I'm like, that divides by 2 again. That's 2 and 27. Uh-oh, that doesn't divide by 2. Does it mean it's done? It divides by 3. So 3 and 9. And 3 and 3. All right, and then we look for pairs. What do we have a pair of? Got a pair of 2s. So they're going to come outside. I got a pair of 3s. They're coming out. The only single who stays inside is a 3, right? My single stayed in. The pair came out. This pair came out. And the guy out in front, he was waiting for his friends. He comes down too. Can you see why I cross off the pairs as I go? You don't want to accidentally reuse those more than once, right? Especially if some of these factor trees get tons of numbers on them. I don't want to lose track of what I got going on. All right, so negative 5 times 2 times 3 is negative 30, and then radical 3. Is there a way to check to make sure this is still the same thing? Like, you guys realize that this is the same thing as this, right? It's just simplified. Just like 1/2 is the same as 5/10. just simplified. In your calculators, because I know some people are like, I don't know if I did it right. You want to double check yourself. Type in -5 times the square root of 108 and see what you get. And it's okay to have a decimal, but just kind of make note of what it is. And then type in -30 times radical 3 times the square root of 3. Is it the same decimal? Yeah. So you know it means the same thing, right? Just like 1/2 and 5/10 are both 0.5. They're the same. One's just simplified. Okay? But if you're unsure, like you get to the end and you're like, I don't know if I did that right, type in the original problem, type in what you have, and they should be the same decimal. So you can always double check to make sure you did it. Why don't you guys try number 6 on your own? Let me give you a couple minutes. All right, guys, let's go ahead and do the last one up here together. All right, so again, you could have went many different routes to your factor tree. I'm going to go 6 and 100. You could do 60 and 10. Oh, man, seriously? That's the same thing Donnie did. You guys both did that. All right, I'm going to go 10 and 10, 2 and 5. All right. So again, it does not matter what route you took, as long as your basic math was okay. 6 times 10 is 60, not 600. All right, so I'm looking for pairs, though. Please, please, please circle your primes. It helps you out so much. But I have a pair of 2s, so they come out. I have a pair of 5s that come out. I have a single 3 and a single 2, which will go under as 6. And then don't forget this guy was already hanging out. So -4 times 2 times 5 is -40 and radical 6. Where do what go? I don't know. For movies, maybe? Dinner? Bob Evans? Yeah, Bob Evans. All right, so how are we feeling with simplifying a radical? Does that make sense? How many of you have learned this before and maybe just forgot? Okay. Like the center of the room. That's kind of weird.